Welcome to the wandering neuron, the place where your mind drifts, learns, and slowly softens into sleep. Before we begin tonight's cosmic journey, gently tap the subscribe button so you never miss another night of soothing science and peaceful exploration among the stars. Now, let's start with a thought that might open the door to your imagination. Every night sky you've ever seen is just the surface of an ocean you've never swum in. Tonight, we step into that ocean, slowly, quietly, and begin our gentle journey to the Andromeda Galaxy. Somewhere ahead, impossibly far, yet peacefully present, is the Andromeda Galaxy, a spiraling island of 1 trillion stars suspended in the cosmic night. For centuries, humans thought Andromeda was just a faint cloud, a smudge in the darkness. It wasn't until the early 20th century that astronomer Edwin Hubble proved that this cloud was actually an entire galaxy far beyond our own. A revelation that expanded our understanding of the universe overnight. And tonight, we drift toward it, slowly, without weight or urgency, letting the vastness around us calm every part of the mind. As your breathing softens, imagine yourself leaving the gravitational arms of the Milky Way. You are crossing the intergalactic bridge, the quiet void between 2 massive galaxies. Out here, the universe feels almost still. The closest atoms are so far apart that space becomes more like a thought than a place. Light travels freely, but slowly, like a whisper moving across a desert. Ahead, Andromeda appears not as a sharp image, but as a soft, pale glow, like a dream forming before it sharpens. Astronomers measure this journey as 2.5 million light-years. That means the light touching your eyes tonight from Andromeda began its journey long before humans existed, long before the Earth resembled anything familiar. Some of those photons may have started traveling toward us when early human ancestors were just beginning to stand upright. As you float through this quiet cosmic space, imagine those ancient beams of light moving past you, patient, unchanged, carrying stories about the birth of stars and the slow turning of galactic arms. Scientists believe Andromeda formed around 10 billion years ago through the merging of smaller proto-galaxies. The stars inside it carry chemical fingerprints of these ancient collisions, traces of hydrogen, helium, heavier elements, and stardust. The same materials that form the iron in your blood, the calcium in your bones, and the oxygen filling your lungs. As you drift closer, you aren't just traveling to another galaxy, you're traveling into the very history of the universe, the material story that makes your existence possible. The light from Andromeda begins to sharpen as your journey continues. You see its elongated shape first, stretched slightly like an oval. That distortion isn't just your imagination, it reflects how Andromeda is tilted toward us. We're seeing it from a gentle angle, not directly from above nor from the side, but from a view that reveals the graceful sweep of its spiral arms. These arms are filled with star-forming regions, huge clouds of hydrogen and molecular gas, where gravity slowly pulls material together until nuclear fusion ignites. Astronomers call these nurseries H2 regions, glowing gently in shades of pink and blue. If you were close enough, you would see newborn stars emerging like tiny sparks inside swirling clouds. Imagine floating through those clouds, watching as gravity shapes them. A single star might take millions of years to form. Yet from here, the entire process feels peaceful, like a slow breath of the galaxy itself. Research from the Hubble Space Telescope and the Subaru telescope have revealed detailed maps of Andromeda's structure, its central bulge, the tightly wound inner arms, and even faint streams of stars pulled from past collisions. These remnants are clues, the galaxy's memories, showing how it grew through the quiet dance of gravity over billions of years. As you approach its edge, the soft glow begins to grow wider, surrounding your vision with a gentle haze of starlight. You are entering the halo of Andromeda, a vast, nearly invisible sphere of ancient stars and dark matter. Some of these stars are more than 12 billion years old, among the oldest in the universe. Here, the silence feels even deeper, timeless, like you're drifting through an ancient library made not of books, but of light.
As you move inward from the ancient halo of Andromeda, the soft haze around you begins to thicken. You're drifting into the galaxy's outer disk, a wide, faint ring where the first organized structures appear. This region contains stars of different ages, but many are older, formed when Andromeda was still young. Astronomers call these older stars population 2 stars, typically low in heavy elements. They glow more quietly with a steadier, gentler light. Tiny clusters pass beneath you, some of them globular clusters, tightly packed families of stars that have orbited Andromeda for billions of years. The Hubble Space Telescope has cataloged hundreds of these clusters, each one like a small star city floating in the outskirts. You continue drifting through the cold, thin gas that makes up the outer disk. Most of it is neutral hydrogen, which astronomers detect using radio waves, specifically the famous 21-centimeter hydrogen emission line. This unique signal allows scientists to map the structure and rotation of galaxies even where the stars are too faint to see. Here, you feel the galaxy slowly beginning to take shape. The spiral arms aren't visible yet, but their gravitational influence is subtle, pulling the gas into soft waves. The outer disk is where galaxies grow, adding gas, forming new stars, absorbing the leftovers of smaller galaxies that wandered too close over cosmic time. As you drift farther inward, the structure finally reveals itself. Andromeda's spiral arms, sweeping, elegant, and full of life. Spiral galaxies don't rotate like solid objects. Instead, the arms are patterns of density, regions where gas and dust are gently compressed, triggering star formation. This concept, known as density wave theory, explains why the arms remain coherent while individual stars move in and out of them. You find yourself passing through bright regions where blue-white stars burn hot and young. These massive luminous stars, O-type and B-type, are only a few million years old. They live fast and briefly, shining fiercely before ending in powerful supernova explosions. Their presence marks active star-forming regions. Clouds of hydrogen glow softly around them. These are H2 regions, places where ultraviolet radiation from newborn stars ionizes the surrounding gas, creating those gentle, pinkish-red nebulae that telescopes like Hubble and JWST have captured. Dark lanes of dust thread between these glowing areas, cold, thick rivers of interstellar material. These dust lanes absorb light, giving Andromeda its rich texture. Some of these dust structures have been mapped in detail using infrared observations, which can see through dust to reveal hidden stars. Everywhere you float, you see evidence of Andromeda's past. Streams of stars, long, faint arcs curve around the galaxy, remnants of dwarf galaxies Andromeda absorbed over billions of years. This isn't speculation. It's confirmed through deep imaging surveys like the PANDAS project, the Pan-Andromeda Archaeological Survey. The galaxy remembers everything. Here in the spiral arms, the galaxy feels alive, slowly turning, creating, dissolving, and renewing. As you move toward the center, the light begins to grow thicker, warmer, more golden. You are approaching the galactic bulge, a dense sphere of older stars that crowd around the core. These stars are mostly ancient,
formed in the early days of Andromeda's history, and their combined glow creates the soft yellow-white light seen in telescope images. Deep within the center lies something quiet and powerful, a supermassive black hole known as M31. Scientists know it exists not because they can see it, black holes emit no light, but because of the way nearby stars move. By observing their orbital speeds, astronomers have calculated that the black hole has a mass of about 100 to 140 million times the mass of our Sun. This value comes from high-resolution spectroscopy and stellar velocity measurements, including data from the Hubble Space Telescope and ground-based observatories. Despite its enormous mass, the black hole is not violent or chaotic from a distance. The surrounding region is relatively quiet, with no bright jets like some active galaxies. Andromeda's black hole is considered low luminosity, meaning it isn't actively feeding on large amounts of material. Around the core, stars orbit in tight, fast paths, some completing their loop in just a few 100,000 years, which is extremely quick by galactic standards. Yet, from where you drift, everything feels still, balanced, serene. The galactic center glows like a warm lantern suspended in the bark. You feel the pull of its gravity, not as force, but as harmony, a sense that all things are connected by the quiet mathematics of the universe. As you float even closer to Andromeda's glowing center, something unexpected appears, something astronomers were once puzzled by. The core doesn't look like one smooth point of light. It looks like two. Andromeda has what scientists call a double nucleus, an extremely rare feature in galaxies. When the Hubble Space Telescope first revealed it, some thought it might be two black holes, but later studies proved something much more elegant. One of the bright points you see is a cluster of old, dense stars at the very center, but the second point is not a separate center at all. It is actually a ring, an elongated disk of stars orbiting the supermassive black hole. Because of the angle at which we see it, the ring appears as a second bright spot. This structure is well supported by research using tools like the Space Telescope imaging spectrograph and adaptive optics from ground-based telescopes. The stars in this region are incredibly close together, so close that from a distance they merge into two glowing shapes, like twin lanterns in the dark. As you drift between them, you feel the quiet choreography of gravity. Each star is following a precise path, orbiting the black hole in a stable, almost peaceful motion. There's no chaos here, only balance. The two shining centers softly illuminate the space around you, forming an inner sanctuary of light at the heart of Andromeda. Leaving the bright core behind, you drift outward again into the softer, dimmer outskirts of the galaxy. But these regions hold some of the most fascinating evidence of Andromeda's history. Here, faint streams of stars stretch across space like long, delicate ribbons. These aren't random. They are tidal streams, the remains of smaller galaxies and star clusters that Andromeda absorbed over billions of years. This is not speculation. Surveys like PANDAS, the Pan-Andromeda Archaeological Survey, have mapped these streams in exquisite detail. One of the most prominent is the Giant Stellar Stream, a long river of stars arcing behind Andromeda. It was created when a dwarf galaxy passed too close and was slowly pulled apart by gravity. Even now, the remnants continue to orbit, wrapping around the galaxy in a graceful loop. You float through these star streams as if you are drifting through the universe's memory. Each star here once belonged to a different home, a different galaxy, before becoming part of Andromeda's story. Their orbits reveal where they came from, how they moved, and how long they've been here. Astronomers use their chemical signatures to trace their origins, comparing them to nearby galaxies and stellar populations. This is how we know that Andromeda grew by merging, by absorbing its neighbors, a process every large galaxy experiences, including the Milky Way. And yet, in this quiet cosmic river, nothing feels violent or destructive. Everything feels slow, graceful, like the universe reshaping itself with infinite patience. As you continue drifting outward, something else enters your awareness: the future. Not your future, not mine, but the future of galaxies themselves. The Milky Way and the Andromeda Galaxy are moving toward each other, slowly but steadily at about 110 kilometers per second. This measurement comes from precise data gathered by the Hubble Space Telescope and refined by the Gaia spacecraft, which tracks the motions of stars in unprecedented detail. Despite how fast that sounds, the distance between the galaxies is enormous: 2.5 million light-years. The collision is not expected for another 4 to 5 billion years, and even when they do meet, it won't be a crash in the way we imagine. Because stars are so far apart, the chances of two stars directly colliding are extremely low. Instead, the galaxies will pass through each other, distort, then merge slowly, like two clouds blending. Gas and dust may compress and trigger new star formation, but the vast majority of stars, including our Sun if it still exists, will simply move into new orbits. Simulations suggest the final result will be a single, huge galaxy, sometimes nicknamed Milkdromeda or Milkomeda. Not a spiral, but likely a large elliptical galaxy. Smooth, bright, and wide. Even here, thinking about the far future of galaxies, nothing feels urgent. Everything unfolds on timescales so vast that they lift the weight from your mind, reminding you how small our worries are compared to the quiet, patient evolution of the cosmos. You drift gently through this thought, letting the perspective soften the inside of your mind, letting Andromeda's distant future become a soft glow that carries you deeper into calm. As you gently drift away from Andromeda's core, the warm golden light begins to soften behind you. The dense bulge fades into the smooth glow of the inner disk, and slowly, the spiral arms unwind beneath your path once more. But this time, you're seeing the galaxy with deeper understanding, with the calm awareness that every star, every cloud, every quiet corridor of light has a story shaped by physics, time, and gravity. You begin to approach the boundary where the visible galaxy starts to thin. Here, the starlight fades into something almost transparent. But what surrounds you is not empty. You are entering the vast dark matter halo of Andromeda, an invisible sphere of mass stretching far beyond the spiral arms. Dark matter isn't something you can see or touch, but astronomers know it exists because of how galaxies rotate. If Andromeda were made only of the stars and gas we can see, the outer regions would rotate much slower. But they don't. They rotate too fast, held together by a gravitational pull that cannot come from visible matter alone. The only explanation that fits decades of observations is dark matter, a form of matter that interacts with gravity, but not with light. It forms a sphere surrounding the galaxy that is 10 times larger than the bright disk, and it contains most of the galaxy's mass. In this halo, the stars are sparse. You might see one drifting alone every dozen light years or more. Ancient stars, some older than the disk itself, relics from the earliest days of the universe. The Pandas survey revealed that this halo is sculpted by countless past mergers, faint arcs, wisps, and clusters of stars, all tracing the quiet history of galaxies swallowed long ago. You drift through this region like moving through the outskirts of a dream, where the shapes are softer, the boundaries dissolved. Far behind you, Andromeda's disk glows like a pale silver coin suspended in black velvet, but the halo still holds you, gently, with the faint tug of its unseen mass. A reminder that galaxies are far larger, far deeper than what meets the eye. As you drift farther away, Andromeda begins to shrink in your vision, but the universe around you grows richer in meaning. You are now floating inside the gravitational neighborhood called the local group, the small family of galaxies bound together across millions of light years. Andromeda and the Milky Way are the two giants here. Together, they dominate the local group's mass, pulling and shaping the motions of smaller galaxies around them. Near Andromeda are several dwarf galaxies. M32 and M110 are its most famous companions. These small galaxies orbit Andromeda like moons around a planet, following long, slow, looping paths influenced by the dark matter halos of both systems. Farther out, you find the Triangulum Galaxy, M33, the third largest member of this group. It is smaller than both Andromeda and the Milky Way, but still a beautiful spiral galaxy in its own right. There is ongoing scientific debate, supported by Gaia data, about whether M33 orbits Andromeda or whether the two are simply interacting gravitationally without a long-term orbit. Either way, they influence one another through gravity, and both are part of this shared cosmic family. Around them orbit more than 50 dwarf galaxies, tiny, faint, ancient systems with only a few million to a few billion stars. Some of them, like the Pegasus dwarf or the Wolf-Lungmark-Melotti galaxy, drift in quieter outskirts. Others dance closer to the giants, pulled into complex paths by tides and dark matter. You drift through this cosmic assembly not as an outsider, but as a witness. The local group spans about 10 million light-years, and everything within it, Milky Way stars, Andromeda clusters, Triangulum's gas clouds, and all their dwarfs, are bound together by gravity. It is a family not of blood, but of mass, a quiet, gravitational harmony. And as you float here, you understand something deeply calming. We belong to a vast structure, but it is still only a speck in the greater cosmic web. Turning slowly, you begin drifting toward the faint, soft glow of the Milky Way. From this distance, your home galaxy does not look like the broad spiral we see in illustrations. You're too far to see the arms clearly. Instead, the Milky Way resembles a flattened, oval glow, like a thin cloud of starlight stretched across darkness. As you move closer, the first thing you reach is not the disk. It is the Milky Way's own dark matter halo, extending hundreds of thousands of light-years from the center. Just like Andromeda, our galaxy is surrounded by an invisible sphere of mass that holds it together and anchors the orbits of distant stars and clusters. Here, floating in the halo, you see the first signs of the Milky Way's outer structure, globular clusters, ancient stellar groups like M92 or NGC 2419, each containing hundreds of thousands of old stars packed into a glittering sphere. These clusters orbit the Milky Way like silent old companions. Their ages, often 10 to 12 billion years, reveal the early history of the galaxy. Many formed when the Milky Way itself was still assembling. You drift deeper and begin to notice something faint but beautiful: stellar streams, long rivers of stars pulled from small galaxies that merged with the Milky Way in the distant past. One of the most famous is the Sagittarius stream, the remains of a dwarf galaxy slowly dissolving into the Milky Way's halo. These streams curve around the galaxy like the strokes of a soft cosmic brush, each one a reminder that galaxies grow by gathering smaller siblings across time. As you continue inward, the halo becomes denser with starlight. The thin outer disk appears, followed by the familiar regions where our own sun resides. A quiet, calm pocket of the Orion Arm, a small spur tucked between the larger Sagittarius and Perseus arms. But the journey does not end here, not yet. You are merely approaching the outer edges of understanding. The galaxy still holds depths, structures, mysteries, and stories that continue far beyond the quiet plane of stars. You float, knowing there is more to explore, and the universe opens itself patiently, ready for the next steps of your gentle journey. As you drift further into the Milky Way, the soft haze of the halo begins to thicken, gradually revealing the thin disk where most stars reside. From this vantage, the galaxy's spiral structure becomes apparent, sweeping arms of stars, gas, and dust rotating around a central core. You glide past faint molecular clouds, dense, cold regions composed of hydrogen and helium, peppered with dust. These are the quiet nurseries of stars. Within them, gravity works patiently, pulling gas into clumps that slowly ignite fusion over millions of years. You can imagine the soft glow of newborn stars peeking through the veils of dust, their light just beginning its journey across the galaxy. The spiral arms themselves are not solid. They are density waves, areas where stars move in and out like gentle tides, while the wave of higher density persists. This pattern ensures a continual rhythm of star formation, a cosmic heartbeat that has been steady for billions of years. Here and there you notice faint supernova remnants, the whispers of massive stars that lived fast and died spectacularly. Their explosions spread heavy elements into the galaxy, enriching the interstellar medium, the very atoms that eventually become new stars, planets, and life itself. Every star you see carries a legacy of countless cosmic generations. Floating slowly, you sense the calm precision of galactic motion. Stars orbit in nearly circular paths, gas swirls in gentle waves, and gravity quietly binds it all. There is no chaos here, only the patient, deliberate rhythm of billions of years. The journey now brings you closer to the Milky Way's central bulge, a dense, golden glow at the heart of our galaxy. Unlike the young, luminous stars in the arms, these stars are older, cooler, and more tightly packed, forming a soft, radiant sphere that appears almost timeless. At the very core lies Sagittarius A star, the supermassive black hole anchoring the galaxy. Its mass is about 4 million times that of the Sun, determined by observing the orbits of nearby stars, some of which complete a full orbit in mere decades. Despite this immense gravity, from where you float, it is silent and still, a calm presence at the galaxy's center. Around it, stars circle in intricate patterns, forming what astronomers call the nuclear star cluster. Observations from telescopes like Keck and VLT have measured these motions with exquisite precision. You drift past them gently, witnessing a delicate dance choreographed by gravity itself. The bulge is surrounded by tightly wound dust lanes, dark molecular clouds that absorb starlight and glow faintly in infrared. These lanes are home to more star formation, quietly ongoing, imperceptible from the outside, but vital to the life of the galaxy. As you float here, you sense a profound balance. Gravity, gas, and light coexist in harmony, forming a living structure that has endured billions of years. And yet the scale is immense. Each star you pass may be hundreds or thousands of times farther from its neighbors than the Sun is from Earth, reminding you how peaceful vast space truly is. Leaving the central bulge behind, you now drift along the Orion Arm, the spiral segment that houses our Sun. Here, the density of stars is moderate, the light soft and familiar. You notice neighboring star clusters, each glowing faintly, and the subtle veils of interstellar dust that give the region its quiet texture. Within these clouds, elements forged in ancient supernovae mix with primordial hydrogen and helium, setting the stage for new stars, planets, and perhaps life elsewhere. It is here, in these calm, nurturing stretches of the galaxy, that stars like our Sun are born. Our own Sun, a middle-aged star of about 4.6 billion years, drifts in the disk at an average speed of 828,000 kilometers per hour around the galactic center, a motion almost imperceptible in the grand scale, yet vital to the stability of the solar system. From your drifting perspective, it is a soft, glowing point among countless others, part of a vast, interconnected cosmic rhythm. Around you, the faint hum of orbital motion continues, stars moving in nearly circular orbits, gas flowing gently along spiral arms, and ancient globular clusters tracing elongated paths through the halo. Each element of this vast system reminds you that galaxies are not chaotic, they are patient, ordered structures, each process unfolding across millions or billions of years. As you continue this serene drift, you feel the calm of space enveloping you. The universe stretches in all directions, vast yet precise. And here, floating among halos, arms, and clusters, you feel the soft connection between your mind and the cosmos, a gentle harmony that carries you further into quiet contemplation and deeper into sleep. As you drift beyond the bright disk of the Milky Way, the glow of familiar stars softens into the subtle, almost imperceptible light of distant galaxies. You are leaving the comfort of the local spiral arms and entering a vast, silent space that stretches for millions of light years. Here, the universe itself begins to show its larger structure, a network often called the cosmic web. Galaxies are not scattered randomly. They are strung along immense filaments of dark matter, forming clusters, walls, and sheets, with enormous voids in between. Andromeda and the Milky Way are connected by one such filament, part of a gentle cosmic scaffolding that supports the local group. Within these filaments, faint dwarf galaxies drift like fireflies, each carrying its own story of formation and survival. Some have been shaped by Andromeda or the Milky Way, their stars stripped away by tidal forces. Others have quietly evolved in isolation, preserving the chemistry of the early universe. Surveys like the Sloan Digital Sky Survey, SDSS, and Pan-STARRS have mapped these structures in detail, revealing an intricate, delicate pattern that is both scientific and awe-inspiring. Floating here, you feel the immensity of space, not as emptiness, but as a calm, deliberate architecture. Gravity weaves everything together, from the tiniest star clusters to the largest galaxy clusters, guiding billions of years of cosmic evolution. And yet, despite its scale, there is nothing chaotic, only an elegant order that allows the universe to breathe, expand, and quietly persist. As you continue to drift along the cosmic web, you notice intergalactic gas, the soft, diffuse plasma that fills the space between galaxies. Although almost invisible, it contains most of the normal matter in the universe, enriched over billions of years by galactic winds, supernovae, and ancient star formation. This gas is the reservoir for future galaxies, the quiet womb where stars and planets will one day form. In some regions, it glows faintly in X-rays, detected by observatories like Chandra and XMM Newton. Though unseen to the naked eye, it shapes galaxies by gently flowing along dark matter filaments, feeding new stars and slowing cosmic isolation. You drift past faint, red and dim galaxies, relics from the earliest universe. Some date back over 12 billion years, formed when the universe was only a fraction of its current age. These galaxies are small and fragile, yet they hold the chemical fingerprints of the first generations of stars: hydrogen, helium, and traces of heavier elements forged in the first supernovae. The intergalactic medium, these dwarf galaxies and the filaments together, form a quiet network of matter, a soft architecture in which galaxies like Andromeda and the Milky Way are just the brightest jewels. Floating here, you sense a gentle rhythm, matter moving slowly under gravity, time stretching across billions of years, and space itself giving way to silence. Further still, you begin to see clusters of galaxies in the distance, faint smudges of light containing hundreds or thousands of galaxies bound together by gravity. The largest of these clusters are surrounded by intra-cluster gas, heated to millions of degrees and glowing in X-rays. You feel a sense of connection as you drift. Every galaxy, every cluster, every filament is part of a vast network. And within this network, the local group is a tiny but meaningful node, a quiet corner of the universe where life, consciousness, and curiosity have arisen. Here, at this scale, Andromeda, the Milky Way, and even our tiny solar system feel like notes in a grand, endless symphony. The universe is not chaotic. It is patient, deliberate, and calm. Stars form, galaxies merge, and dark matter guide them all. Yet everything moves in a silent rhythm that stretches across billions of years. Floating in this infinite calm, your mind drifts with the universe. You begin to feel a soft, profound sense of perspective. Your thoughts, worries, and plans are tiny compared to the cosmic dance. And in this quiet, you can let go, letting gravity, time, and light carry you gently deeper into sleep. As you drift even farther, the local group becomes a small cluster in the vast darkness, and the faint glow of our immediate galactic neighborhood softens into tiny points of light. You are now entering the realm of galaxy superclusters, immense structures where hundreds or even thousands of galaxies are bound together by gravity. The local group itself is part of the Laniakea supercluster, a cosmic continent spanning over 500 million light-years. Within it, galaxies flow along invisible rivers of gravity, all moving toward a common center, a region of slightly higher density called the Great Attractor. Even at these enormous scales, the motions of galaxies are smooth and deliberate, like a slow, endless river, tracing patterns invisible to the naked eye but clear to telescopes. Here, galaxies of all shapes and sizes, spirals, ellipticals, dwarfs, float serenely through space. Some are brilliant, star-filled islands. Others are faint, ghostly remnants of ancient structures. And yet all are connected by the vast, nearly invisible web of dark matter and intergalactic gas, forming a network both delicate and resilient. You drift through this landscape quietly, your mind absorbing the calm of these colossal scales. Time here is different. Billions of years feel like minutes, and the immense motions of galaxies are soft, gentle currents carrying stars, gas, and dust through the universe. As your journey continues, the individual galaxies begin to blur together into a tapestry of distant light. Clusters and superclusters merge visually into soft glows stretching across the void. Light from billions of galaxies reaches you, each photon a messenger from the distant past, carrying stories from billions of years ago. Some of these photons began their journey when life on Earth did not exist, when the first stars were igniting in a universe still young. Others started traveling toward you long before the Milky Way itself had fully formed. Each is a reminder of cosmic patience, of the slow, deliberate unfolding of creation. Floating here, you begin to feel a profound sense of perspective. Your thoughts, worries, and plans are tiny compared to the cosmic dance, and in this quiet, you can let go, letting gravity, time, and light carry you gently deeper into sleep. Slowly, you feel the universe start to pull you back toward your own mind, your own space. Andromeda, the Milky Way, the local group, and all the distant galaxies fade gently, like stars receding into a quiet night sky. The journey is complete, but the calm, the perspective, and the cosmic rhythm remain with you. You have seen the past and future of galaxies,
floated through star nurseries, drifted along tidal streams, and glimpsed the endless architecture of the universe. Now, as you lie comfortably, allow the silence and vastness to carry you deeper into sleep. Let the gentle hum of the cosmos lull you. You are part of this universe, yet peacefully small, drifting safely in its immense and quiet embrace. And before you drift fully into your rest, remember this: the universe is patient. Time is long. Stars are born, live, and fade. Galaxies merge, drift, and persist. And you, in your own gentle way, are part of this endless, beautiful rhythm. Good night, traveler. Good night, dreamer. Sleep among the stars, carried by the soft light of Andromeda, and awaken with the calm of the cosmos in your heart.